Hello class, this is going to be a lesson on exponential growth and decay, and also we're going to go a little bit more deeper than we did in first semester. First of all, this is page number 6 out of your notebook, and we're going to start by reviewing exponential growth and decay. Okay, if you remember first semester, we talked about this equation before, where f of x means final amount, a means the initial amount, b means the rate of change, and x is the number of time periods. Also, if the problem deals with percentage, you also want to use a 1 plus or minus, okay, the rate of change raised to the x. Okay, so let's take a look at these problems right here. Example first problem says Clara invests $5,000 in an account that pays 6.25% interest per year. After how many years will her investment be worth $10,000? Well, first thing we need to ask is, what is our final amount? Final amount is $10,000. Okay. What is our initial amount? Initial amount is $5,000. And then, are we dealing with percentage? Yes, we are. So that means we're going to open parentheses. I'm going to put a 1. And are we going to add or subtract? Well, in order to decide that, you kind of have to read the problem. And if you notice that your money is increasing, right? You're starting with $5,000 and you're hoping to end up with $10,000, so your money is going up. So that means you're going to add the interest, which would be 6.25, but remember, you need to change percentage to a decimal. How do you do that? There's two ways. One, you write 6.25 and you move the decimal point 2 decimal places to the left. So in other words, you get 0.0625. Another way to do this is just on your calculator, punch it in 6.25 and then divide it by 100. Okay, basically that's what percentage means, per 100. So 625 divided by 100. Alright, so here we have our equation. We plug it into the formula, and that's what we got. Now what we have to do is just solve for x. And if you recall from the previous lessons, this is an exponential equation, so this we have to solve for x. So what we're going to do is we're going to divide both sides by 5,000. So 10,000 divided by 5,000 is 2. 5,000 cancels. This is 1.0625 raised to the x. Okay. Now how do we get the x low? Well, we're going to do log on both sides of the equation. And if you remember, once we have logs, we can take this x over here and move to the front, because that's one of the properties of logs. So I'm going to write over here, log of 2 equals x log of 1.0625. Now, to get the x alone, we're going to divide it by the log of 1.0625 on both sides. The log cancels. I'm left with x, and then all I need to do is divide that in the calculator, and when I do that, I'm going to get 11.4. Okay, so following this example, why don't you stop the video right now and try example number 2, and then when we come back, we're going to see the answer for example number 2. Okay. Hello, welcome back. Basically, you should have tried example number 2, and let's see what you should have done and what answers you have achieved. Okay, basically the question is the value of a truck new for $28,000 decreases 9.5% each year. Predict when will the value fall to $5,000. So basically same question. What is my final amount? My final amount in this problem is $5,000. My initial amount is $28,000. I'm dealing with percentage, so I need to add the 1 minus, because the value is decreasing. Okay, you also can see it that final is 5,000. The initial value is 20,000, so the numbers are decreasing. So we need to change this to a decimal, so this will be 0.095 raised to the x. And now we just have to solve the equation. So we're going to divide it by 28,000. That cancels. Here we cancel the zeros. And you can write just as a fraction 5 over 28. And 1 minus 0.095 is 0.905 to the x. And to solve for x, all I have to do is do the logs on both sides. So this will be the log of 5 over 28 and log of 0.905 to the x. The reason why we do log is because we want to move the x to the front. So this will be the log of 5 over 28 equals x, log of 0.905. We're going to divide both sides by the log. Logs cancel, and if you punch in this in the calculator, make sure to put parentheses here. Okay, and the answer should be 17.3. I'm going to leave it up here a second in case you want to copy or need to correct anything, or you always can pause the video. Now we're going to proceed to the next problems. Okay, basically this is what we saw last semester at the very end. Okay, and also let's do one more problem similar to that. We're going to skip example 3 for now. We're just going to do example 4. Okay. The problems we have been doing so far, it has been done annually, compounded annually. That means the bank is paying you one time a year. Okay. So the bank is promising you in this situation here that, let's assume that you deposit $1,000 in the bank with an 8% annual interest compounded annually. In other words, the bank's going to pay you one time. What is the balance after 1 year? How much money are you going to have in the bank after 1 year? Well, we have our equation, right? F of x equals a times b to the x. Do we have a final amount? No, because that's what we're looking for, the balance. So that would leave us x. Okay. Then we're going to do our initial amount, which is $1,000. And then, since I have a percentage, I'm going to put a 1. And because we hope our money is going to increase, so we're going to add the percentage, which is 0.08. And in this problem, they give us the time, which would be 1 year, so it goes right there. And if I punch in that in the calculator, that tells me that in 1 year, I'm going to get in my bank account $1,080. So that means that if I leave the money in the bank for one whole year, the bank's going to pay me $80 for having that money in the bank. Okay? So if I put the money in January, okay, then January of next year, the bank's going to pay me that $80. Okay? Now the thing is this: if for any reason you take that money out before, let's say that January, then the bank doesn't have to pay the $80. Okay? Because the bank is only going to calculate your compound your interest 1 year after your deposit. Okay? Now that leads us to talking about a little bit more about compound interest and the different types of interest that we have. Okay? Before we talk about this equation, I'm going to demonstrate here this example step by step, and then we're going to use the equation to show you how the equation help us, the formula help us find the answer real quick. Okay? Let's suppose we have the same scenario. I have $1,000. The bank is offering 8% annual interest, but it's offering to compound quarterly. Quarterly means 4 times. So that means instead of paying one time only, the bank is going to pay you in 4 different times. Okay? So if you don't want, you don't have to write this, what I'm going to write. But basically, you're going to start, let's say in our scenario, we're going to start with $1,000 in January, right? And the bank is offering 8%, but it's going to divide that payment in 4 different payments, right? So 8% divided by 4 would be 2%, right? So in other words, the 3 months runs by, and the bank it's time for the bank to pay you. So the bank's going to pay you 2% of the money that you have invested. Well, 2% of 1,000 will be 1,020, right? So in 3 months, now you have 1,020 in your bank account. Alright, another 3 months go by, and the bank's going to pay you again. So now he's going to multiply the 2% based on 1,020. So now you're going to have in your bank account $1,040.40. Okay, and then another 6 months go by, and the bank pays one more time. So now this time you have $1,061.40, and next January, the following January goes by, and now it's time to make the final payment. So the bank's going to give you now, or you're going to have now in your bank account, $1,082.43. Okay, so that's what the bank's going to do if the bank offers you to pay quarterly. Okay, there's 2 advantages to that. You already noticed, but compound annually, you get 1,080. Compounded quarterly, you get $1,082.43. So you do get a little bit more money by compounding quarterly. Now, some people might say, well, $2 is not much of a difference, but it's your money, and every penny counts, right? Another reason why this is better is the following. Let's go back to our scenario. Suppose it was January, right? And let's say in November you have Thanksgiving, and you go shopping. You want to go shopping for Christmas presents for Christmas, right? So you want to use your $1,000 because you're running out of money, and you want to make sure you have all the presents ready. Well, if you go to the bank and take out that $1,000, guess what? If you have compound annually, the bank will not pay you the $80 because you're supposed to have the money the whole 1 year in the bank. Okay, So that means if you go in November and take out your money, guess what? The bank is not obligated. The bank will not pay the $80 that you're supposed to have, because the bank is going to only pay it in January. So you're not supposed to touch that money. Now let's look at this scenario. Okay, this is 3 months, 6 months, 9 months. So to September, you have this amount of money in your bank account. So in November, if you need money, you're welcome to take out money out of your account, and the bank will not pay you the remaining interest, but you'll be able to take out 1,061. So that's the advantage of compound quarterly. Okay. Now, like I promised you, there is a formula that helps us calculate the balance in your account. Instead of having to do this step by step to get to our final payment of 1 year, there's this formula. The formula is A stands for balance or final amount, P stands for initial amount of principal, and open parenthesis 1 plus the interest rate, the number of times the bank's going to make payments, raised to the number of payments times the number of years. So let's see how it works for this situation. Okay. In this problem, we're looking for our balance. So this is going to be our X. Okay. Our principal, or our initial amount, we deposited $1,000 in the bank. Okay. And open parentheses 1 plus the interest rate is 8%. So we exchange the decimal, so the 0.08. The bank is paying quarterly, so that means 4 times. So we're going to make 4 payments. Close parentheses, raised to 4, which is the number of payments, times the number of years. In this case is 1 year, so it'd be 1. Now you might want to put a parenthesis there when you put in the calculator. Okay, even though you know that 4 times 1 is 4, but on future problems it might be 4 times a weird number. So when you put in the calculator, you want to put that parenthesis there. Okay, well, if you punch that in the calculator, you will get the 1,082.43. Okay, so this equation here, or this formula here, is very important because it allows us to find the final amount that you're going to get in your bank if the bank is going to pay you compound quarterly. Okay, so using this example here, let's go ahead and do example number 5. Give it a try following these examples. Okay, you don't have to do this. This is just to illustrate how the bank is working every 3 months. Okay, but for example 5, I want you to apply the formula and see if you get the answers. Okay, so stop the tape and try example number 5. Hello, welcome back. We're here on example number 5. So let's remember our formula is A E 1 plus R over N times 2. I always like to write down my formulas, especially when I'm first learning them. Alright. A stands for final amount. That's what we're looking for. So we're going to put X. Our principal is $5,000. 1 plus the interest rate, which is 6%. And our payment is quarterly, so we're going to divide it by 4. So 4 goes here again. And now we want to know our balance in 25 years. Make sure you put parentheses there. And if you plug this in as it is on your calculator, you should get a total of $22,160.23. Okay. If we do it monthly, this would be, let's write the formula again, help us remember when the test comes and stuff like that. So it's a good practice to write down. Okay. we're looking for our balance. Our initial amount was $5,000. 1 plus the interest rate, which is 0.06, divided by the number of payments. If it's monthly, well, there's 12 months in the year, so I'm going to put number 12 there, and 12 over here times the number of years, which is 25. Now we're going to plug this in the calculator, and we should get the answer of $22,324.85. So, as you can see, the more payments that bank gives you, or the more number of months, or the greater the number of times the bank compounds the interest, the greater is going to be your return. Okay, so if you have a choice between quarterly and monthly, pick the monthly. Okay, and so forth. All right. So these are kind of key words that you want to look when you look at when you do the homework tonight. Is watch for the keywords quarterly, monthly. So if you see those words, you want to use this formula. If you see annually or each year, you want to use this formula. Okay. And the last thing we're going to talk about today is something called continuous compound interest. You know, that is like if your interest was being compounded almost every second. We have a special formula for that, which is A, final amount or balance, equals P, which is the principal or initial amount, number letter E, raised to the interest, times the number of years. So here I have an example where we're going to compare a quarterly compounding versus continuous. Okay, so I'm going to start with the continuous because that's the new thing we're going to do. Okay, here is the situation. You deposited $10,000 in an account that pays 6% interest. Find the balance after 10 years if the interest is compounded continuously. So we know our formula. We'll write it down. We want to remember. Okay. Final balance, that's what we're looking for. The principal, how much money we put in, $10,000. E is a constant, so we'll just write E. The interest rate is 6%, so 0.06, and then times the years, which will be 10. Make sure you put parentheses here when you enter the calculator. Okay, and if you punch that in the calculator, you should get $18,221.19. Okay. Now remember, if you see the word quarterly, you're going to use a different equation. Because that equation, so if you remember, is A equals principal, open parenthesis 1, interest rate over the number of payments times the number of years. So we're looking for the balance. The principal was $10,000. 1, interest rate is 0.06. The number of payments, if it's quarterly, that means 4. So that means this would be 4 times, we're talking about 10 years. And once you're in the calculator, make sure you put parentheses over here and also over here. So your answer will be $18,140.18. Notice continuously is more payments than quarterly, so this is giving a better return on my money. Okay. Alright. So here's your homework. It's going to be homework 4.2. Okay, so go ahead and put 4.2 there. And in these problems, you want to watch out for the keywords. If you see annually, then remember you want to use this formula here. If you see the word quarterly, monthly, daily, then you want to use this formula here. And if you see the words continuously, then you want to use this formula. Okay, there's a few corrections that we need to make over here on the answer key. Okay, number 2, double check here. Here we go. It's supposed to be 2,938.66, and this is a typo. Yeah, I'm sorry, I made quite a few mistakes here. This would be 32.5, and the rest should be okay. Alright, thank you for your time. I hope you're able to understand, and go ahead and do the homework, and then when we come back to class, I'll be more than glad to answer any questions you have. Thank you for your time and attention. Goodbye.